All right, we're going to look at number 9 in section 5.6. A particle moves in a straight line with the given velocity of 12 minus 6t meters per second. Find the displacement and the distance traveled over the time interval from 0 to 7 seconds. That's what that means. So I just graphed our function to help us out here, right? The graph of 12 minus 6t, of course, is just a line passing through the y, the v-axis, I guess, at time 0 at 12, and then moving down basically what, 6 meters basically down every second. So by 2 seconds, we're at 0, and then we're negative velocity for that. So keep in mind, what's the negative and positive velocity? Well, for say we're moving left and right, positive velocity would be to the right, negative velocity to the left. If we're moving up and down, right, positive velocity up, negative velocity down, for instance. So displacement is just integrating the actual velocity function. So the velocity function is 12 minus 6t. Using FTC1, pretty easy. Antiderivative 12 is 12t. Antiderivative 6t is 3t squared. Evaluated at 7, evaluated at 0, and subtract, I get negative 63. Of course, that's going to be in meters. So what's that mean, negative 63? Well, if we're moving right and left, at time 0, we're at some point, and then 7 seconds later, where are we at? We are 63 meters, what, to the left of our position, right? Because this is negative, left of the starting position. So that's what displacement means. Does that mean we traveled just 63 meters? No, right? Because apparently we were moving to the right for a little bit and then moving back to the left. So wherever we start at, we move to the right a little bit and then we move to the left. And by the time 7 seconds comes, we're actually 63 meters to the left. So we got to figure out how far we travel this way and then all the way back. And the way to do that, of course, is by integrating the absolute value of the velocity function, right? That's how we find distance traveled. So what is the absolute value? Well, from 0 to 2 seconds is just the velocity function. So from 0 to 2, I'll integrate the velocity function. But from 2 to 7, notice we've got to bring it up, right? Because we would be accumulating negative area. Of course, that's why we got this negative 63 here. And we want to count that as positive area, right? We don't, we're still, even though we're moving to the left, we're still traveling distance. So it's -1 times that velocity. Basically, the absolute value function would look like what? It would coincide with this part here, but then this part, right, would look like this. And so we need to multiply by -1 to do a reflection essentially in that horizontal axis. So -1 times that gives me -12 plus 6t. So I just evaluate these two integrals. Very easy to do. The antiderivative of this one is 12t minus 3t squared, same as we had above. Evaluated at 2, evaluated at 0, and subtract, I get 12. For this one, antiderivative of -12 is -12t, and the antiderivative of 6t squared is plus 3t squared, just the opposite signs of what we had over here. Plug in 7, I get -84. 49 times 3 is 147. And this is 63. Minus, plugging in 2, I get -24. 3 times 2 squared, 3 times 4 is 12. So this is -12. 63 minus -12 is 75. And adding, I get 87 as my answer. So for my problem, again, your numbers might be slightly different, but for this problem, we got 87 meters rather. That's the distance traveled compared with the displacement, right, which was -63, meaning we finished 63 meters to the left of where we started from. Okay, I hope this helps.